So agenda of today's session is to understand the layer of AI architecture. We're going to discuss about data layers, AI model layers, and we're going to discuss about application layer. We're also going to discuss about security monitoring layer. Actually, when you're talking about AI architecture, we talk about three important layers. And entire AI is basically worked on the three important layers: data, model, and application. And that's something. And along with that, we also going to discuss about security. So total, we have a total four layers based on which the entire AI is working. So this is the architecture we're going to discuss, and then we're going to discuss about the governance point. What are the governance point? How to manage the governance of AI architecture? So that's something we need to discuss. So first, we need to discuss about the basic introduction, which is talk about the key components of AI system and what is AI architecture, right? Because that is also important for us to understand. Now, when we're talking about architecture, okay, let's take an example. Okay, uh, so we have a land here. Okay, we have a land. Okay, so on this land, I want to construct a house. To build a house, what are the resources are required? What is the thing? What is the most important resource we require to build the house on this land? The most important thing is money. Without money, nothing is possible. So money is required, but how much amount of money is required? That matters. Agree? So we need a workers, we need building materials. But the question is, one thing is common in all three things. I'm sure everyone agree with me. How much money, how much worker, and how much building material? Is everyone agree on that part? Right. Definitely people have a money. We have a resource, we have building materials, but what is the quantity we required? And that is where we get a visibility based on the architecture, where we design the entire layout of the house. That's why I started with this topic on imagine you want to build a house. You would not just start buying a brick or wood and nailing them together. First, you need to plan a detailed plan of architecture, and that is basically blueprint. Is it clear? So we need a window that has a cost. I need a drawing room, that is a cost. I need a bedroom, that is a cost. I need a balcony, that is a cost. So that layout provide me visibility based on which on this particular land I will construct the house. Am I clear? So architecture is basically provide the blueprint that shows every room, window, and door that will have to go. It include the plan for the invisible systems like where electrical wires, plumbing pipes will run. So it define the rules like the house that must be strong enough to withstand with the high wind and all that. The same thing we had a workout plan. Let's say example, you're going for a marathon. You are going for a marathon. So it is a marathon for the 14 kilometers. Your current lifestyle is like you're not going to gym, you're not going gym, you're not having a proper nutritions, you're not having a proper diet. Is it clear? Based on this particular current state, is it possible for you to go for running? My question is that based on this particular thing, is it possible for you to go for running? I don't think so. So what you did, you decide, you plan that okay, you need to go gym, you need to have a nutrition, you need to have a proper diet plan. So what you do, you create an entire workout plan. Is it possible after having a biryani of 1 kg, will you go for the gym? We have agreed we need to have a nutrition. No, right? So first we need to have a running. We have to go to gym. Then we need to have a breakfast. Then we need to have a yoga. So by this workout table, we can able to plan our activity properly. Am I clear with everyone? And we get a visibility where we need to repeat the activity. So architecture help me to reuse my resources in a more cost effective manner because it give me idea. Okay, gym I'm going in the morning, gym I'm going in the evening. So there is a repetition, but we know how to use this repetition. Am I clear? Or I'm basically using the nutritions and I'm using a nutrition in such a way I can reuse that. So architecture basically provide me that visibility. So architecture is a high level plan that actually define the major part of the system and how those parts are interact and rule that govern them. We have a strategy, we have a program, then why there is a need of architecture, right? Because strategy talk about the rule, program talk about the rule, yes or no? Strategy talk about the desired state, strategy talk about the business objectives, program talk about the scope. Then why we need an architecture? So always remember one thing, the first thing what we create is a strategy. Is it clear? The first thing what we create is a strategy which talk about what you want to achieve. Like we will build a family home with a 3 bedroom. Is it clear? That is basically my desired goal. Now that will be translated into the program. How you manage the work, like plan, budget, and team. That is basically called as a program. Like hire the contractor, order materials, set deadline. And then you need to connect all these dots. And this is where the program feed into the architecture, which is act like a framework, where each piece fit and how everything is connect. Understood? Understood, team? So three reason why we need an architecture, because clarity for the builders or clarity for the consultants, and it basically also provide the visibility of how we can build the safe and reliable things, and more important, if any future changes is required, we can do without tearing the whole things. Is it clear? Now enough for this house building and all that. Now we jump into the actual thing what we are here, which is called as a AI system architecture. So AI system architecture is a structure blueprint that basically outline how data is collected, process, analyze, and deliver in a insight manner. Is it clear? That's something we're going to discuss. And in architecture, we organize the entire AI architecture into 4 layers. First is data layer, second is model layer, application layer, and security and monitoring layer. But do you know there's a one more layer is missing? What do you think? Data layer is there, AI model is there, application layer and security monitoring is there. What do you think? One, which layer is missing here? Governance. Governance is a continuous process that we do in all three, all the phases. Presentation layer part of the application layer only. The most important layer is the infra layer. Do we need a control over the infrastructure also? Definitely. That is a base. Agree? Infrastructure layer is the most important base, right? But why we have not covered this? Because we're talking about right now solution of AI. Okay. And we're talking about how to optimize the AI. And that's why we're talking about the AI architecture. Is it clear? So before I jump into the topic of AI system architecture, let me show you how that entire flow works. So I will zoom it. Okay. So here what happened, we have divided the entire thing into 4 parts: security, data, AI model, and application layer. Let me zoom it so you'll get a better visibility. Okay. So here, if you can notice, this is basically my data layer. We're going to discuss each and every layer in detail. Right now, I'm just giving you the complete visibility. What is that? Okay. So first is basically called as a data layer. Base of AI is the data. And that is why the starting point is basically data. So here you can see we have a batch sources, streaming sources from where we're getting a data. Now, what is this ETL? We're going to discuss later. Okay. Then we pre-processing those data, and all the data is basically stored in data storage. Is it clear? And how, so what is the governance we adding? Governance is this section. Governance like data lineage, classification, consent, quality, access governance, compliance, and all that. So we applying this governance on the data which is we created and stored in a database. Is this clear? This is the source from which we collecting a data. Is it clear? And this is the governance we apply on the data. Like data without classification has no value. So we need to qualify, we need to classify. That is part of a governance. And by governance, we enforce a policy on the stored data. Security control, like encryption, we apply on the stored data. How we do that, we'll discuss later. So this is basically the first layer, which is called as a data layer. Now, once the data is ready, the most important, the backbone of any AI is basically the model. Model is a black box. It is like a brain. Now here you can see the data fed to the algorithm. The model is the one which decide how to produce the output of the input, which is entered by the user. How important is the model? Can we say model is like a brain and heart of AI? Because model is basically the one who process the input and provide the output, right? But provide the output from where? The database. So data splitting is there, training of the data has been done, validation has been done, tuning has been done. But on that, we need a proper governance before we deploy. And this is the governance: explainability, model manage, fairness, drift, approval workflow, training governance, and all that. And once the model is basically trained, we basically need to provide this accessible to user. So here we have a user activity like, workflow, decision support, web UI, and all that. Is it clear? But what kind of an output we need to control? It is controlled with the help of governance, like validation. If any user enter any kind of malicious queries, make sure it should not produce the PI informations and all that. So we have a proper governance. So one thing I want to ask you this: governance work parallelly in all the phases, or governance is a one-time process? Need your reply in the chat box after seeing this diagram. Governance is a continuous process which is parallelly work with other, or it is basically separate. Governance parallelly work in all the phases. But do you notice something here? Security layer. Security layer is the backbone, because if you can notice from this point, okay, if you can see the security from this point, okay, I think you will get more visibility. Give me a second. And we're going to discuss this table again, okay? Now here you can see there is a one data pointer is happening here. Can you see this? Some data. These data pointers are coming from the application logs, and that is basically going to security. And the future is basically this, where we monitor with the logs, and we can see with the Elbow dashboard what kind of an output is happening. Am I clear? And then whatever
Yes.
we need to control, we provide the inputs, and according to that, we improve the models. So all the data pointers, whatever is coming from the application model and all that, all are recorded in the logs. And from the logs, it goes in a dashboard. And here I can see what is happening in my AI. And based on that, I can basically provide all the options to the AI architecture. Is the basics concept is clear? Now, here what happen is, if you go by the, so I'm taking one reference of one of the body. Okay. So I will share the source also. So if you see the actual AI architecture, it has the three things: AI infra, AI deployment, and AI development and deployment. Is it clear? Now, when you're talking about AI infra, that providing me the key inputs, which include the compute, expertise, and data. Okay. How much computation is important? If you're talking about AI, how much computation is important? Is it most important? So one is that you simply deploy the computation, and second is you define proper what to control, what not to control, and all that, which is a good practice when it comes to governance. If you're allocating a computation, whether it's a CPU, RAM, GPU, and all that, it should be have a proper governance. Is it clear? We need a definitely a necessary skill set to perform the activity, and data is basically the most important point. And when you're developing, the most important part is model. In the previous section, we already discussed that. And then we basically deploy this in our application, and that's something we are going to push. Okay, so this is something we have a high level. Now, nowadays, what happened? Some companies are building an AI, they're taking a model from some other party, and they're deploying in someone else's infrastructure. Have you seen such kind of an architecture? And the best use case is ChatGPT and OpenAI. You took the OpenAI model for somewhere else, deployed in some other cloud, given the development to someone else. So you can imagine what is the level of threat you have when you're building the AI with the decentralized functions. And without governance, if you're just deploying the other, it's a blunder you're doing. Literally blunder you're doing. Am I clear? So it's very important. If you're basically splitting this activity, make sure you should have a proper control over the things. Is it clear? Make sure you should have a proper controls on the things. So that something is part of the function. That's how we say we start with the input here, like secure the compute, assemble the expertise, collect the data. Then we basically trained a foundation model. Infra is a one time, right, Harish? We can get during a development model enhancement is a basically play a very important role. AI infrastructure is standby. Cloud is basically provide that. But the most important part is how you train your model. And how much investment is required is depending upon how you train your model. How many agree with this? Is it true? Then also one important thing, what is your fine tune model? Okay, you need to check the specific behavior. Do you notice deep seek, okay, deep seek and DeepSeek and ChatGPT, do you see any difference in their output in terms of their inputs and all that? How they basically process? DeepSeek is basically providing more insights. Okay, Javier, sometime what happen is we already have a predefined data. Understood. But how you fine tune that basically matter. Understood. That's the point I'm saying. Data is always static in nature. The one thing which we need to make dynamic in nature is your model. Is it clear? So models need a fine tuning time. It's a continuous process. So fine tune that effectively so that it can have a specific behaviors and business domain. It should not reveal any information. So that's the most important part. And during this time only we select what is a strategy you have to use for releasing. You need to keep it private. You need to sell API access or open source, and then you can embed in your product. Is it clear? So that is basically the process we have. The basics are clear now. Start with the infra, collect the data, build the application, fine tune it, choose the release strategy. You want to make it in-house, you want to close, or you have to use the open source. And then you can basically embed it in a mobile app, chatbots, or analytic dashboard and start releasing the things. So let's start with the first part, which is basically called as a data layer. So far, those who are not from the AI background or are beginners, are you guys able to connect these examples and all that? The basics? Okay, so let's get started with the first part. Now, when you're talking about data layer, okay, yeah, definitely, Sumit. So when you're talking about data layer, okay, so data layer is a foundation component. Okay, this is where the raw data is gathered, okay, clean and store and setting the stage for model building. Is it clear? So if I take example of ChatGPT, let's take example of ChatGPT. So ChatGPT, Chirag and Ganesh hosted on any infra. Agree? Infra basically mean RAM, CPU, and storage. Right, Chirag? So that layer is basically the infra layer. Now, ChatGPT, when you enter something, you get an output. There is a model behind that. We need so team. My question is for everyone is that from the when you born your first year, and if you compare first year with today, do you see any difference in your thought process? Definitely, and that experience basically change your thought process. So moral of the story is that when we're talking about model is like a brain. You have to fine tune with the more data and all that. Is it clear? So that is basically called as a model. Okay, and then the application, the user level, which connect, chat GPT interface and all that, that is basically application layer. Is it clear? So all those things are basically required for the functions. Am I clear? So these things are basically part of the parameter. Okay. So when we're talking about the functions, okay, so we have a, so when we're talking about the data, so data layer is a foundational component. Okay, so that's why we're starting with the completely zero. Is it clear? So data layer is a foundational component where the raw data is gathered, cleaned, stored, and setting a stage for model building. Okay, so Chirag and Ganesh and everyone, now it's clear, the basics are clear. So now we're going to start for everything. Okay, so first component is called as a data. So in the data, we have a three things: ingestion, pre-processing, and storage. What is that? Now we're going to discuss that. Okay, so when we're talking about these components, the first we're going to discuss about data ingestion. Okay, so team, what do you mean by English word data ingestion? What do you mean by word data ingestion here? Because when we're talking about first data architecture, because we have skipped the infrastructure, okay, because this is something you definitely buy. So what is data ingestion? Intake of the data, can we say? Let's say example. Remember recently LinkedIn, without your permission, enable one setting on the profile where whatever you enter the post and all that, it will collect all the information. Did anyone notice that? LinkedIn basically enable one of the settings in everyone profile that whatever you feed, they will start collecting all the data. Why? Because they're building a AI. What you enter in the Google, they maintain the data. That is a Google. Amazon, when you basically checking his sales insights and all, they're collecting data. So that is basically called as a data ingestion. Data ingestion as a concept is clear. Collection of data. Collection of collection of data. Is it clear? or you can say a real-time source. So that is basically called as a data ingestion. First one clear? Now in the data ingestion, there is a one statement I'm sure you have seen everywhere. It is uses ETL. ETL. Okay. So how many of you have heard this word first time? And that's completely fine. And how many of you know this word but never understood what is that? Because in AI, the most important part is the ETL. So here what happened is the first thing is called as a E. E basically stand for extract. E stand for extract. T stand for transform. And L basically stand for load. Am I clear? E basically stand for extract. T stand for transform. And L stand for load. Okay, it means extract, transform, and load. Is it clear? So when you're collecting a data, okay, we utilizing a ETL pipeline. Okay. Today we're going to discuss, sorry, don't worry. So we're utilizing a ETL pipeline to integrate your heterogeneous data. Is it clear? So first step is basically when you're talking data injections, we're talking about, so what ETL does, let's first understand that. Okay. ETL. Please understand carefully. Okay. Let's take example. You went to market. You went to market. Okay. And what is the first thing? You need to pick the vegetables. Yes or no? You pick the vegetables. So picking a vegetable, okay, is just like a getting data from the source. First one clear? That is called extract. Second is basically called as a transform. Transform is basically what? When you buy a vegetable and you bring vegetable to the home, what is the second thing you do? You simply cook or you wash? For me, I believe we should wash. That is something I learned. So same like you wash, you bundle the vegetables. So in data format, we clean the data to remove the noise and we format. Is it clear? Third, as I said, we have a E, T, L. So E basically extract, T mean transform. Transform basically mean you convert into the format which they can understand, or some simple like you wash the vegetables. Is it clear? And third is basically called as a load. Load is basically mean you put the vegetables on a grocery stores, or you put the data into the new system, or you basically when you bring the vegetables in the house, you cut it and you organize in a proper manner in a fridge. So that is called as the ETL. So now understood what is ETL? Extract, transform, and load. Is it clear? So we are using this thing, and this is the technique ETL we use in the method called source. Now we have a different source for collecting data: database, API, sensors, logs, social media, IoT devices. That is a source we have. Second is we have a method. Method mean we utilize some kind of a batch processing for a data dumps, and we have to streamline the pipeline for real-time data flow. So we look for the API and all that. And that is the reason for that we're using a tool technique called first is ETL. So ETL is clear. Now, second technique we are using to collect the data, we are called as a, I don't know whether you remember, notice this called Kafka. Have you heard about this concept called Kafka? K-A-F-K. Kafka. I'm sure you heard about this, Kafka. And there is a one more thing called as a NIFI, N-I-F-I. Trust me, after today, you will definitely remember this, Kafka and Nikki. So because whenever you're working in the AI and all that, I'm sure you will heard this word always, Kafka and NIFI, N-I-F-I. Now, when we're talking about Kafka and NIFI, just imagine these are Apache NIFI we called. So just imagine these are like a specialized delivery systems. Is it clear? So Kafka is just like a high-speed conveyor belt for data that is constantly be produced. And NIFI is just like a visual tool where you can drag and drop the design. Understood, team? Kafka is just like a high-speed belt for data that constantly been produced or sent. And NIFI is just like a visual tool where you can drag and drop design the entire delivery model. So that is basically the method by which you collect the data. So data ingestion is clear. So you collect the data. Now, question is when you're collecting a data. Now, here the governance section. When you're collecting data as a governance person, what you need to do? Do I need to introduce the AI guardrail? What is a guardrail? When you're collecting, make sure you should not collect. We should not collect PI information. So, do you think so? Here we need to apply PI filter. Now you're getting my point. How are you introducing governance in architecture in the design step itself? Okay, collect only minimum data, privacy by design, log all the data. So during our tools and techniques, make sure minimization is there, filtering is there, and no PI data to be collected. Because once you obtain, hackers by entering any prompt can generate the data. That is why data ingestion from a security point of view, from a governance point of view, is a very, very important part need to be understand. Because once you collect, you can't do anything. Now, once you collect the data, the second step is called as a data pre-processing. Data pre-processing is the most important pillar of the AI because what it does, it clean the data. It does the cleaning. Second is it standardize the data. Okay, standardize the data, and more important, enrich your raw data. Is it clear? To ensure you have a best possible input for your machine learning model. Am I clear? Arif, I've just given an example of only PI. We're going to discuss the guardrail. Okay, so more of the story is that in a data processing, pre-processing, we are normalizing. Normalizing means we convert the data into the common format that everyone can understand. Or you can say like that, it's like a better ingredients lead to the better final results. So data pre-processing cleaning step is clear. So cleaning is basically what it does is it removes the noise, it handles all the missing values, okay, and it will filter out all the errors and resolve all the inconsistency. That is the first part of the role, which is called cleaning. Second is basically called as a transforming. Now during a transforming, we're doing a normalization. We encode all the data is required for the downside application. And the most important part here, we're talking about this feature engineering. What feature engineering does is it extract and create a meaningful feature that basically used to improve the model performance. I repeat again, feature engineering. See, we clean, remove the noise, we normalize with the help of transformation. And third, we are basically using the concept of feature engineering. Feature engineering, as I said, is basically mean you are processing the entire end-to-end data. Is it clear? So Mohit, for your point, ETL is basically it is the high level formatting to organize in a particular thing where this cleansing or this transforming is basically converted into the detailed format of data for a particular brand. Is it clear? That something is there. For more information, I can say, let's say example, you have organized carrot, potato, but now what happened? You have a carrots, you have a potato. To ensure they cook at the same rate, you chop them into the similar piece, right? So organize into carrot and potato is a part of your ETL. Chop into pieces, organize into the particular thing is basically part of a transformation. Am I clear? But now what happen is, when you chop into things and all that, you need to map it 0 to 1 because computer understand that. So this basically prevent one feature from dominating other. So this is how we're doing that. Is it clear? So feature engineering is the most important part of the function. What it does, it extract and create a meaningful feature that basically help you to improve the model. Is it clear? Let's take an example. We have a two type of entry here. Let's take example. We have a two type of entry. Customer underscore purchase. Customer underscore purchase. That is a one thing we have. And second is basically we have a sign up underscore data. Is it clear? So there are two entries are there. Customer underscore purchase and sign up underscore date. Is it clear? So instead of using a separate entry called customer purchase underscore data and sign up under data as a separate feature, you can basically engineer as a new feature, which is called day underscore as underscore customer. So by this way, what happened? We can pull all the data in a one format. Is it clear? So instead of using a different feature like customer purchase underscore data, purchase underscore date and sign up underscore date, instead of creating a separate feature, we make it as a one days underscore as a customer. So why? So this is what is called as a feature extraction. So this new feature often much more predictive and meaningful to the models. Is the basics are clear? So what we're doing is whatever the data duplicacy we have, we can organize into the one particular things. And by that, we can able to integrate the things. So hope this is clear to everyone. Okay. So now what happened is one more important thing, the thin line difference between the ETL and we are talking about during data pre-processing is that making a data consistent is a part of ETL. Make the data ready is part of a transformation. Mohit, understood? I repeat again, make the data consistent and usable is part of a ETL. And make the data ready for the model by doing fine tuning and all that is basically called as a part of transformation. Am I clear to everyone? Okay, so that is the thin line difference we have. Okay. So now what happened is we're talking about the next, but here what happened is we're talking about the governance. Okay, what kind of a governance we require during a cleansing? Okay, do you need to track the source? Do you need to have a automatic data quality checks? Do you need some kind of a version controls if any kind of modification happen? That's something we can introduce in the concept of data pre-processing. Is it clear? That can be done. The third most important thing, once you're done with everything, now it's time to deployment. So we have a data lakes, data warehouse and all that. Is it clear? So here what happened when you're storing a data, we have a three things. Storage solutions are there, scalability performance is there, and proper data governance is there. So when we're talking about storage solution is basically talk about, you know, the type and volume data you are storing. So we have a two type of data here, raw, or you can say structure and unstructured. Actually, by end of the day, we store in that format only. Is it clear? So we have to understand after cleansing and all that, what how much percentage structured data we have, unstructured data we have, that we need to see. Second is scalability performance, where we need to ensure the storage infrastructure support the high speed query. So do you need a fault tolerance here? Do you need a RAID here? RAID, redundant array of independent disk. So you have to make sure they can able to process data more faster. And whenever we store data, it should be comply with the GDPR, DPDP and HIPAA. Is it clear? And this is how the entire layers is basically defined. Is it clear? So we will have some kind of a controls here. Let's say example, we have a control like access controls. We can have a encryptions. Okay. And we can have a logs because these are basically provide the insights. And these are basically called as a key component of the data layer. So this is how we have defined. So I have used the IBM structure diagram. You can see data source, years of data. Then we have data preparations, the month of data, which we training sets and all that. Then we using a model to enhance and everything. And then we're trying to connect that, which provide the insights. Is it clear? So now we're going to discuss about the second, which is called model. But before that, now we're going to discuss about how the governance begin. So as I said, in the data layer, we have a data source, we have a ingestions, we have a data pre-processing, we have a labeling, and we have a storage. So we need some kind of a governance controls. Like when you're collecting data, make sure you should classify the data. Is it important? Like, see, if you talk about any company, right, we only have a three type of data. Regulated data, second is business data, and one is called as a operation data. You take any company, we only have a three type of data: regulated data, business data, operation data. Let's say example, PII, you're doing a business in Europe. So your PII data is, need a reply in the chat box. Your PII data is basically, what do you think? PI data is part of regulated data. Trade secrets, business process, BRD documents are business data. SIM logs, system logs, transaction logs, operation data. Is it clear? So first thing is that I'm only going to collect the data if it's classified. Second is source validation is important. Definitely. You cannot simply pull the data from any random source because wrong data provide the wrong output. Is it clear? And nowadays what happened, we also have a licensing for the data. Okay. Someone's data was dumped. Now, live example, chat GPT. Tell me frankly, there's no harm in that. A lot of people, what they do, they simply upload the copyright PDF in the chat GPT. Yes or no? To just extract the summary, insights, and everything. Is it a breach of copyright? Definitely. Right now, the AIs are not mature. They are not giving any error. They simply take the PDF and provide the insight, like Google Notebook LLM, Gemini, Chat GPT. Yes or no? Does it give you any error? I don't think so. They will give you any error. They simply take and extract, but it is a breach. So nowadays, what happened when you're building something around data and all that, make sure you should have a proper legal check for that. Because tomorrow you are using a AI and someone file a notice. that your model generating output which is more aligned with my copyright stuff. So make sure whatever the data we're collecting, you should check the legal. Second is when you injection data, logging, authentication, rate limiting is required. Rate limiting is basically maintain the flow of data. So that is also very important. And when you're doing a pre-processing like cleaning, filtering, pre-processing mean you're removing a noise and all that. Make sure you mask the PI data if you collect it, minimize the data and all that. And rest is basically for the storage. We have encryptions and all that. So these are basically things we required. Is the basics are clear? So when you're building an architecture, these things you need to consider. Is it clear? So now question is why data layer is matter? Because governance start with the data, so trustworthy input you will get, security privacy is there, regulatory compliance is there, repeatability, auditability is there because without data you can't do audit. So that is why this layer is important. Now next is basically called as a model. So what is model team? That is called as a data layer. The second is basically called as a model. What do you mean model? Okay. So if you basically take the example of model, can we say model is like a brain of AI? Even you have a right data, but model, if it's not properly governed, it can basically backfire. And initially ChatGPT does the same thing. So if you ask me, AI model is the most important thing because AI model is where the core intelligence of system is developed. I will explain you why. See, we have a three things here. One is basically called as a data. One is basically called as a information. And one is basically called as a intelligence. Okay, so we have a data, we have a information, and we have a intelligence. Is it clear? So all three are same or different? Okay. So let's say example, there is a data of 1.1.1.1. I collected from 4 computers. So single computer I collected 1.1. That is called as a data. From 4 system I collected, it become a information. Can we say 1.1.1 attack system A, same system attack B, same system attack C, same system attack D. Or let's say example Prakash. Prakash data found in database 1, 2, 3. So single database information is called as a data. But when I combine this information, can I say I am able to create his profile, like what he purchasing, what he buying and all that? That is called as a information. And then on that, we apply the intel. Like definitely every salaried man will do some kind of investment in the first week of the month. Am I clear? So data is a raw, information is a meaningful things, and on that you apply the intel. So which layer in AI build the intel? Which layer in the AI build the intel? The answer is model. Because AI model layer is where the raw data become a actionable intelligence. So do you think so we need a more governance in this area? And you will be surprised to know that 95% chances, if you're not building a AI internally, this is where you lack because they're providing you the box, they're providing you brain. Model is a brain, and you have no visibility because that is called as a black box model. How many agree with that? Maximum people will be using AI. Very few are building internally. And maximum glitch come in the model layer, and you need to have a proper governance in the model layer because governance here guarantee every model is lawful. Okay, it's not mentioned here lawful, it should be ethical, it should be secure, and more important, it should be continuously accountable from the first line of code. Is it clear? And that is why the model is the most important thing where you have to spend good amount of time. Is it clear? Now in the model we have a three things. We have a model training, model validation, and model deployment. What do you think? What is the first thing when you're talking about model layer? The first thing is basically called as a model training. Is it clear? In model training, we have a four important things: algorithm selection, data splitting, computational resource, and more important, the framework and library. So let's understand with the example. So when we say in model, so first of all, model as a concept is clear. What is model? So AI model is like a recipe that computer follow to make the predictions. Is it clear? Let's say example, you go to you basically go to out for a restaurant. to have some food. They have a kitchen, they make a food and provide to you. So can we say kitchen is a model? Yeah, kitchen is a model because there you can see chefs are there who learn by tasting many dishes. The data you give it to it, number, word, image. During a training, they basically taste every food and all that, and according to that, they do that. Is it clear? We're going to discuss, Prakash. Don't worry, we're going to discuss. So AI model is a very important part. Is it clear? This is where we create, we list down all the data, we learn the ingredients, we learn how to taste the data, and then we basically finish the things. Is it clear? To identify this is the picture. Is it clear? Okay. So we're going to discuss that part also. Don't worry. So when we're talking about the model training, and model training is basically start with the first thing which is called algorithm selection. So how many agree? Like if you don't choose a right algorithm, okay, you will not able to produce the right data. Now here the algorithm like decision tree is there. Okay, decision tree is there. We have a neural networks. Okay, we have a support vector machines. Okay, so we have a different type of algorithm, and that is based on the problem type. What kind of a problems we have? Is it clear? Okay, so when we talking about the uh, uh, algorithm selections, so we talking about here classification of data. Okay, then we basically talk about we're talking about clustering of data. So that is something is most important part we have in the algorithm selections. So algorithm is basically very important. What kind of algorithm using that basically matter. Now second part is called as a data splitting. Okay, second is basically called as a data splitting. That is something is the next part. So once you select the algorithm, the next we have a data splitting where we divide or divides the data into training, validations, and we test the sets to ensure the model can learn and generalize the output. Is it clear? So data splitting is a process where whatever the data we have, we will train the data, we validate the data, and more important, we test the sets to ensure like this is the cat, this is the dog. So we are doing a testing. So that is basically part of a data split. Is it clear? Third is called as a computational resource. Like we're using CPU, we're using GPU to perform the intensive computations, especially for deep learning tasks. That is called as a computation resource. And finally, we have a framework and libraries. So what do you think? What are the framework and libraries we are using here? What is the framework and libraries we are using here? What is the framework and library we are using? Or do I need to discuss again? I think some questions has been raised. Can you repeat again about algorithm selection, about this classification, regression, clustering? Do you want me to discuss again this part? I can discuss that again. Okay, let's discuss. Okay. So when I say algorithm selection, I think everyone knows about what is deep learning and all. That's an algorithm, but it's also depending upon the type, which type of uh, data you're using. Is it clear? So which kind of problem you're addressing. So first is classification. Second is basically called as a regression. Third is basically called as a clustering. And fourth is basically called as a ranking. Listen carefully. Okay. So picking the right algorithm is depending upon what kind of a question you are asking. Am I clear? Hello? Picking the right algorithm is depending upon what kind of a question you want to ask the chat GPT or chat AI. Is it clear? So first is basically question type called classification. Example of classification. Uh, I'm uploading an image of buckets. Please let me know in which bucket cat is there. So here we are uploading a picture and we tell the AI to recognize in which box we have what element things. Understood? Hello? Or you uploading a picture and you're telling them, okay, identify which one is a right box, which one is a black box. Let's say example. So here the goal is to identify the objects. Is it clear? So we are using the random forest algorithm. We are using a logistic regs and all that. Second is called as a regression. Regression is what. So let's say example, what will be the future stock price? Investments. Current value of the stock price is this. What is the future price? So that is basically kind of a regression question we are asking. So according to that, we need to select the algorithm. Is it clear? For that, we have a boosting regression and all that. Is it clear? Third is basically called as a clustering. Clustering is like you group the similar things with no label and tell them, okay, identify what data it is. So that is called as a clustering. And the fourth is called as a ranking. Ranking is you basically drop a queries around, list the best option for travel. Is it clear? So these are basically kind of a questions you're going to ask AI. So you have to assume here what kind of a questions your AI going to answer, so that according to that you will select the algorithm. Am I clear, team? Now is it clear? Is it clear? So that is the most important thing. Second is basically called as a data splitting. We already discussed. Okay, but here there's a challenge. Do you notice free chat GPT? Okay, sometime becomes slow. Free chat GPT sometime becomes slow because of data size, because of training speeds. Is it clear? So when you selecting this algorithm, you have to check the constraints also. What is the data size? What kind of a interpretability is required? Training speeds, budget, hardware, data types, all those things are required. Is it clear? So that is why algorithm selection is a most important part is model, because that is the one which drive your computational resources and all that. Is it clear so far? Next is basically called as a frameworks and libraries that we are using. So frameworks and libraries, I don't know whether you heard about this concept called, have you heard about TensorFlow? TensorFlow. Have you heard about TensorFlow? And second is basically called as a PyTorch. Let me explain you. So TensorFlow is like a framework developed by Google. It's basically a powerful workshop which provide complete end-to-end system for building your training, deploying, and large set of complex model. Okay. So you can say it is known for its industrial strength and scalability. And PyTorch is basically developed by Meta, Facebook. Okay, and this workshop is known for being more flexible, okay, intuitive, and more important, easier for experiment. So nowadays, if you're talking about researchers using these frameworks to build the learning modules, is this space is okay with everyone? So TensorFlow and PyTorch are basically the frameworks and libraries we are using to train your data. Is it clear? That is basically the primary purpose we have. Okay, so these are basically part of the model training. So model training is clear now. Algorithm selection, data splitting, selection of computational resource, because more computation we have, more data we can able to train. And then the framework libraries we are basically using. But have you heard about these? Is all three are same? CPU, TPU, and GPU. Is all three are same, right? CPU, GPU, and TPU. Okay, how many of you all not aware about this? You heard about, but no idea. Let me explain you. So we always start with a CPU to build the prototype. Understood? So when we're talking about computational resource, CPU is basically called as a central processing unit. Is it clear? Like every laptop they have. GPU is called as a graphic processing unit, and TPU is called as a tensor processing unit. Tensor, TEN, tensor processing unit. Listen carefully. Okay. So we have a standard family sedan. Sedan car is an example of, what do you think? You have a standard family sedan car, which good at many tasks, not built for heavy hauling and all that. That is your CPU. Okay. There's a sport car with many tiny engines. Okay. Built for parallel cruising and all that. That is called as a GPU. A custom race car tuned only for AI workload. That is called TPU, which is basically called as a tensor processing unit. Understood the basics? So here what happen is when we talking about the CPU, GPU, how we start. So when we building a prototype, na, we use CPU. Let me explain again. So if you're talking about like it's like a family sedan car, Narendra. Family sedan car is a CPU. Clear? Small to medium models, data prep we can use for that. Is it clear? Second is called as a GPU, graphic processing unit, a sport cars. You can say with many tiny engines and all that, which is a deep use for deep learning, training, and fast inference. Then the clear. And third is basically called as a TPU, which is basically used for massive scale tensors and all that. Okay. So when you're building a prototype for the model, we use CPU first. Then so first we basically have a CPU in which we build the prototype model. Then we move to the GPU. Okay. Which basically when the training is basically slow. And then we basically move to TPU only if you are pushing very large deep nets in the Google Cloud. Is it clear? So flow is also matter. Now here what happened, as I said, we have a TensorFlow and we have a PyTorch. Is it clear? So TensorFlow is basically what? It's a framework. It's a library which we use a workshop for processing of data. Is it clear? So if you're looking for heavy duty factory, production grades, GPU and TPU are basically using a TensorFlow. And PyTorch is basically used for rapid prototyping, which use a GPU. So these are basically the frameworks, okay, we are using for modeling of the training of the data. Is this clear now? What is that PyTorch and this called TensorFlow and PyTorch? So framework is nothing. It is a it's basically workshop you basically build to make the model more fine tuning and prepare for the deployment. Is it clear? So hardware is your CPU, GPU, TPU, and framework is your TensorFlow and PyTorch we are using for the processing. So now the model is ready. The next thing is basically called as a model validation. But hold on here. There is a catch. Now please listen this carefully. We need to introduce proper governance here. Okay, so there's a bank. Okay, they want to train a fraud detection model, FDM, fraud detection model. So they're using a random data for classifications and all that. And here what happened, the data was split. 70% is trained, 15% is basically validate, and 15% is being test. I repeat, this is trained, this is test. Sorry, first is trained, second is basically validate, and third is basically called as a test. Okay. Okay, so we data split is 70% is trained data, 15% is validation, 15% test. So this is running on EC2 with GPU using a TensorFlows and all that. So here what happen is when you're selecting a model, you have to make sure you record the data. You use a training context, make sure we have a proper access control to the training data, and make sure we should log the data. So now understood what is data splitting. So we can able to categorize how much right data we have, how much we have validated, and how much we need to improve better. So that is why data validation is very important. Now next is basically called as a model validation. Okay, model is ready. Now next is basically what? Performance metrics. Okay, cross validation testing. And third is basically mean hyper parameter tuning. So what is the meaning of that? That's a question. So when you're talking about model validation is the most important part of building a model. Okay, so first part is called as a performance metrics. Now, what is performance metrics? So we're using a metrics like how accurate. So we look for the accuracy. That is the first thing we have, accuracy. Second, we basically look for the precision. And third, we called as a recall. And fourth is called as a F1 score. Actually, these are called as a performance metrics. I repeat again. One is basically called as a, you can say accuracy. Second is called as a how precise it is. Third is called as a recall. And fourth is basically called as a F1 score. So what is these are the metrics. So let's understand. So first is called as accuracy. What is the meaning of accuracy here? So in simple term, accuracy mean what percentage of a questions did student answer correctly? It means correct response. Is it clear? Simple and straightforward. Is it clear? So we have to see the AI, how percentage it can be correct. So that is called as a performance matrix. Simple and straightforward. For me, the student is who? AI. For me, the student is AI, right? So how much it is correct, how much correctly he basically do, that is the most important part. Second is basically called as a precision. Precision is basically mean, imagine you are grading a spot the cat. Let's say example, spot the cat. So we are doing a test, spot the cat. Is it clear? So precision basically ask about, is this student labeled as a cat or it is actually a cat? Is it clear? It actually measure how trustworthy is the positive predictions are. Let example, if you enter something, how precisely it produces the same thing. Nowadays, what happen in the chat GPT AI image generate? Does it generate the exact image what you want to build? Hello? Not necessary. Okay. So it is not possible 100% they can do that. That is called as a precision. Precision basically mean about grading. Is it clear? Trustworthiness. Is it clear? Third is basically mean when you enter suppose a group of pictures of a cat, group of picture of dogs, identify the count. That is basically called as a recall. Recall basically ask about, let's say example, actual cat in the picture. Okay. So how many did the student find? So it basically measure how thorough the model is finding all the positive. Sometime happen, we upload the image, we say identify the important thing from the image. So how much it can able to recall. That is basically called as a performance matrix. So performance matrix clear? Now last part is basically called as a F1. F1 score is basically the combination of accuracy, okay, precision and recall. Based on that, we basically give the grade. So that is basically called as a F1 score. So when you're talking about performance metric, these are the performance metrics we have. Second is called as a cross validation and testing. Cross validation testing basically talk about truly understand the material, not to memorize. Okay, so we take the context, review the things, validate from the multiple source, and look for the correlation. That is called as a cross validation testing. That's another important thing we have that we need to look for. Is it clear? So we employ techniques like cross validations to assess the model and make sure it should not generate a different output. And we need a proper control there. And third is basically called as a hyper parameter tuning. That's the most important part of the AI. Okay, so it adjusts the parameter to optimize the model performance. Is it clear? Let's say example, if you want to study, we study for maximum 1 hour. Is it clear? Or we should study for 1 hour, 3 hour with music or silence. So these are settings are called as a hyper parameter. Am I clear? What is the best way student can study? 1 to 3 hour with the music, without music. So these are basically called as a hyper parameter tuning. So that's something we need to look for. And according to that, we validate the thing. So what kind of a governance control we can introduce here? We can document all the test results. We can look for the bias and genders fairness check. Remember Amazon case, use case Amazon 2015. They only filter the CVs of male. So it means hyperparameter tuning is missing there. Their performance metrics are tuning is missing there. Okay. So we need to balance that. We need to make sure average model accuracy we look for is 95%, 92% and all that. Is it clear? So that's something we have to look for. So these are the metrics we are using for the functions. Is it clear? And once you basically build the model, you need to deploy the model. Okay. So here we have a containerization. Okay. We prepare the model for productions. Okay. Then we look for the deployment method, how you want to deploy with the help of microservices or cloud base. And then you need to monitor for the productions. So these are things we will basically look for. So we have some controls here. That's something we have to look for. Example like training with the label data. Okay. Because when you're doing a modeling, label data is important. How many agree with that? When you're working on the model training, training with the label data is important part. Is everyone agree with that? Because if you don't label it, you don't know what data we are using. Is it clear? So we have explanatory testing, bias audits and everything. Then we look for the model evaluations. We need to have make sure performance metrics and everything. And when you deploy, make sure it should be deployed with the proper logs and we can able to track all the model iterations. So these are basically the necessary functions we have that we need to look for. So is the model is clear to everyone? Now, next is basically called as a application layer. Now, when you're talking about application layer, this is where the user is interacting. When you open the chat GPT, you enter the queries. That is basically called as the application layer. So application layer is where the AI system interface with the end user. That is basically called as a application layer. And here we have a two important interface. One is basically called as a user interface. And second is basically called as a business process integration. I repeat again, here we have a two important component. user interface, and business process integration. So when we're talking a user interface, we have a front end application and UI. Like you can see the interface when you enter Google Gemini, that is basically called as a UX and front end. But from the back end, they're pulling the data, and they're pulling the data with the help of API services. They look for the workflow and decision support. So API mean you're connecting with other servers. That is called as a API service. Okay, and workflow is basically mean you're embedding your AI into your fraud detection system. Nowadays, you have noticed now when you log into any app and all that, in the backend they have a decision support systems or workflow automations. Nowadays, what happens is a lot of website using chat functions and all that, which is AI. So that is basically part of a workflow automations. Is it clear? So here we embedding the AI into the business process like e-commerce, fraud detection mechanism, and all that. And it also providing a decision support, which a tool enable the human to make a decisions. So these are basically the business process integrations we have that we are using. Now, question is what kind of a governance control we need in that case. So let's say example, the first thing is that API gateway. Now, please listen this carefully. Okay, API gateway is very important because when you're pulling the data and all that, you need to make sure. So let's say example, this is Google. Let's say example, this is Google. This is Amazon, and this is something AI I built. So this is the model. Is it clear? And this is basically the application where the user is sitting. So this APIs which is integrated this model, make sure the right API to be integrated. Okay. Can we simply inject any API? Can we simply inject any API? Can we start pulling data from random source? No. So make sure if you're connecting the API, we need to have a proper authentication. If I'm pulling a data from Google, it has a secret code authentication that need to be authenticate first. Then only I can able to pull the data. So API gateway is very important. And in that, what kind of a governance we need? We need a proper authentication. We need to make sure prompt filtering is there. I don't know whether notice nowadays if you have we have did this kind of a trial. If in the chat GPT, if you enter any kind of abusive words and all that, chat GPT or Google Gemini will not react. They will not provide you the output. It means they have now prompt filtering. Okay. And if you try to enter multiple queries, abuse rate monitoring is there, it will delay the process. So these kind of a governance control now they introduce. So by this, we can reduce the load. On the other side, the chatbots, dashboards, and all that, what kind of a data we need to tell them? We need to show them. So that basically give an access based on a role base, transparency notice, and make sure consent capture should be there. That's why whenever you're trying to log in and all that, you can see these kind of a things. And last part is called as a feedback loop. Feedback loop mean whenever the user input to the model, we take the data, we review the data, and if we found something abuse and all that, according to that, we can do the test. That's why nowadays in the chat AI based tools, we are doing a A/B testing. A/B testing. So that's something we need to discuss now. So first of all, please check this diagram. Okay, if you notice here, the first thing what we have API gateway, which is like a front door for every request to model. Is it clear? So now what happened? Do you notice when you log into ChatGPT, they're giving you option login, Perplexity they're giving you login, or any AI tell you to login. Why? Because when we enter, we need to have ID. So we can able to see from which location they're trying to access. And what we can make the attacker out, we can have a OAuth and OpenID rate limiting on the controls. And make sure we should log everything. Second is inference of the microservices. Microservice basically mean we're taking the application for multiple things. Make sure no raw PI payload should be logged. Container image, if I'm taking, it should be signed. And SBOM need to be used, which is called software bill of material. All the business logic that we use in AI, make sure we mask all the personal field. It should not collect the data. And any changes in the business logic need to go through a change management process. So these are basically the high level of subcomponents we have on the application layer. That's something we have to look for. Now, next is basically called as a security and monitoring layer. So security monitoring layer is crucial for maintaining the integrity, reliability, and compliance. So when you're dealing with AI, what is the most important thing? Confidentiality or integrity? If you're dealing with AI, what is the most important priority? Confidentiality or integrity? The first is integrity. Make sure it should provide the right data. And then we have to make sure it only generating a right output to the right user. Is it clear? So it basically oversees the complete layers of the AI. Is it clear? So the key components here is like we have a security measures, we have a logging and auditing, and more important, we have a performance monitoring. So these are the things we check in the AI. So in security monitoring layer, we divide the entire stuff into three sections. Now listen carefully. The first is basically called as a security measures, where we talk about the threat detections, we talk about the access controls, and we talk about the encryption and data protection. How? So what happen is when it comes to threat detection, we implementing the anomaly. Controls. Anomaly mean abnormal thing, it need to be recorded. So we configure the baseline if someone sending any kind of a queries, you know, which is not been expected, it should be logged. Second is anyone want to access the chat GPT or any AI, it need to have a proper authentication authorization. And according to least privilege, they get a right output. Third is whatever the data is generating and stored in storage, you need to have a proper encryption, especially data in transit and data at rest. So we make sure we should have a proper encryption there. And when it generating a prompt output and all that, if sensitive information is there, make sure it should be masked. That's the first thing. Second thing is that have you heard about the key vault which is called HashiCorp. So if you're using a third party API and you want to use the key, you can use HashiCorp to integrate the key. Is it clear for key vault? Now you want to log the information also, because what you're doing, you want to log. So logging is important because it track the accountability, right? So you have to record all the critical events, what kind of a data has been accessed, how the model has predict, what is the error, what is system changes. So we implement the centralized logging tool to collect all the logs and everything. Is it clear? Along with that, we have audit trails. Audit trails basically recreate the entire activity. Audit trails mean a set of logs you collected. Why? Because of the compliance reasons. Audit trail mean there's a user who tried to log in at 6:30 and access till basically 7:30. Let's take example 6:30 to 7:30. So entire activity from 6:30 to 7:30 I want to track. Is it clear? So we maintain the detailed logs that support the compliance with legal regulatory requirement, which can be used for the post auditing. Today in the AI, to record these logs, we use one concept which is called as a blockchain. I'm sure everyone heard about this blockchain. So we use blockchain architecture where once we record, no one can able to alter. And that is one of the best control you can use for audit trail. And if you're looking for the performance monitoring, the first thing we need to have a real-time metrics. Okay, where we look for SLAs, uptime response, model drift limit. That's something we can look for. And any kind of a deviations are there, we should record. Like it should be. You need to set up the anomalies or performance degradations with the incident management process. Any point of time, AI model is basically degrade or it generating any kind of a data and all that. We can integrate with the incident management and make sure we should have a proper dashboarding which provide the comprehensive view of the system performance. So we are using Grafana, Datadog, and everything. So that's something we can have. So there is a one dedicated governance control I have discussed here. You can see for threat detection, we can use Cloud SIEM with custom anomaly rules. For access control, we can use IAMs and all that. For the logging activities, we are using API events and everything. And another important element we are using is here is Grafana dashboards and all that. So these are things which is part of the functions. Team clear? Okay, so this is basically part of the functions. It's just a high level. Okay, so now we're going to discuss about the governance. Now we're going to discuss about the governance in the AI architecture. Okay, governance in the AI architecture. So now we're going to start the actual thing. So when we're talking about governance, so as I said, we have a data, we have a AI model, we have an application, and we have a security monitoring. So on the side of data, the typical building block is ingestion, cleansing, and all that. But what is the risk when you're doing the privacy breach and bias injections? Agree? Yes or no? So that is there. Second is basically When you're talking on models and all that, we work on the pipeline, registry, validation. What is a risk? When there's an unexplained bias, adversarial manipulations, and more important, the drift is there. So these are basically there. Now, another important thing we basically talk about here is application. So workflow is there. Okay, UI decision support is there. What is the risk? If someone is entering some other queries or opaque decisions and all that. And when it comes to security monitoring, we basically have a IAM, SIM, SOAR, and all that. But risk is basically undetect attack and non-compliance. So when you're talking about building an AI architecture and locking over the governance, these are the primary risk we have to govern. Is it clear? That something is part of things. So how you build the governance? What is the starting point? The first, you need to adopt the NIST RMF. Okay, start from the phase one itself. Okay, so you can able to govern, map, and measure and manage. Then once you basically do the risk assessment, now it's time to decide the controls. And for the controls, you can use the 4201. And nowadays what happened, we have a model specific frameworks, when you're building models, which is basically using to build the model functions. Is the basics are clear? Use the RMF to do the risk assessment. Control selections will be do with the help of 4201. And if you want a next webinar on NIST AI RMF, do let me know. I will basically plan the practical of NIST AI RMF very soon. Okay, and last is basically called as a sector specific MRM, which is basically models. So it's a sector specific models we have that we are using, and we have to look for the validation. So the question is perhaps how to start. The question is basically how to start. That's the question. The question is how to start. So first is basically we need an inventory. Now inventory classification. Is it clear? Data classification, source classification, and all that. Is it clear? That's the first step. Then every data that we collect, we basically do the risk impact mapping. Okay, so you can apply 4201 NIST to do that. Then when you're collecting data, you design the controls like privacy by design, secure coding, and all that. And then you will do the testing by doing an adversarial test, robustness test, and all that. Then you deploy the model and AI in the deployment. Then you basically run. Then you do the audit and make sure you produce the report. So these are typical artifacts we have that we collect in the AI governance architecture. Like data model, like SBOM is required because you're looking for the data and model. Risk register is required to document the risk. Then you need to make sure the model should able to explain what is that. So we're using sharp and lime, which is a very common thing for model expandability. Actually, this is basically talk about how your model works. Is it clear? We don't have a time to discuss that. So if next webinar, we'll discuss that. Then when you're deploying the image and all that Docker code signing is there, that something is part of the functions. Then we use Grafana Datadogs, which is a monitoring and everything. And with the help of orchestrators, you can integrate and RACI metrics we are using. So the key takeaway, if you talk about, is that if you're building the AI, the first thing is that you need to embed control in the pipeline. If you introduce control in the later stage, it will be more expensive. How many agree with that? So you need to treat policy as a code, and you need to automatic PI scanners, policy gates are required. So it should be start from the stage one. Is it clear? Second is unify the risk language. When I say unify the risk language, basically mean you adopt one framework and map with 4201. I repeat, you can adopt NIST and map with the 4201. That can be a good starting point. Third is make the lineage immutable. Okay, it means from a raw byte to predictable, every hope need to be hash chain. So that provide the integrity. Next is called separate the duties. Development team will be done development, validation team will do validation, production will do production. There should be three separate team. Next is automate drift. Automate drift is basically mean you tie the monitoring layer, you basically look for any deviations and all that, and continuously educate the people of how to use AI. But one thing is missing here. One is called as a guardrail. Have you heard about this? In AI architecture, this is a turning point, guardrail. So if you basically take the example, guardrail. So it is basically a buzzword nowadays in the industry. Is it clear? It is basically a buzzword nowadays in the industry. What is a guardrail? Let me explain you. It is like a AI. You are right. So let me explain that. So guardrail is what? It is built in a safety boundary that block or redirect anything that might send your AI system off course. Is it clear? Sometimes what happen na, when your relatives comes and they basically talk about good thing about you, good thing in a different way. So parents in a control your emotion, don't react. So can we say parents are the guardrails? Hello? They are like a automatic brakes and steering locks. Can we say yes or no? So guardrails are not a paperwork. They are like a automatic brakes and steering locks. Is it clear? That keep your AI system safe, lawful, and trustworthy, no matter who at the wheel. Is it clear? So what happen is when we're talking of guardrail, let's say example without guardrail, what happened? The model leak personal data, engineer basically deploy untested models, and there is a prompt injection jailbreak trick the chatbot to reveal the source code. That is basically without guardrail. But with the guardrail, all the requests are filtered. The CI/CD gate refuse a deploy analysis test, and we can have a prompt sanitizer and all that. Is it clear? And we have a guardrails in every layer. Like in the data, we have a PI filters. Is it clear? On a model, we have a bias test. During a deployment, we only deploy which is a signed container. When enter anyone queries and all that, we have input sanitizers. During a runtime, we have a drift alarm. It means if auto alert, if accuracy drop 3% below, we can get a notification. And then we have a logs, which is write once every predictions. So these are basically the practical guardrails we have, which used to achieve the particular governance. Is it clear? Because if you can see here, if we have a PI filters, what it does, it basically prevent the privacy breach. If you have a model build, it basically stop discriminatory predictions. Is it clear? If we have a sign content mean like digital signatures, it basically prevent tampered or rogue model in production. Okay. If you have a input sanitizer, it can basically prevent from injecting any kind of a queries. Remember, once upon a time, ChatGPT was generating a Microsoft serial code, serial numbers for operating systems. So because of the API prompt and input sanitizer, we able to control that. Is it clear? Sometimes what happen, we have a drift which is running on the runtime. So what happen is if any point time response prediction value go low, then it keep the outdated model from silently harming the decisions. And more important, we can able to record all the logs. But now question is in the AI governance, from the architecture perspective, how you design the guardrails. The question is, first is list your risk. So what do you think? What are the risks we have? Privacy is a risk, bias, IP theft, regulated reputation. Do you think these are the list of risks we have? It depending upon which kind of AI you are building and in which industry you are. How many agree with that? Is it true? So that define your list your risk. No videos there on YouTube which talk about this. It's a very important thing. Recently, we did the project for that. So please listen this carefully. So when you're building an architecture, it's very important. You need to know the guardrails. Is it clear? So first is list your risk. Then define your red line. Define a red line basically in what is absolutely acceptable, like no PI ever in the logs. Okay, Saksham, just take a screenshot of this slide. Okay. Third is basically pick the enforcement point. Pick the enforcement point mean what is the data pipeline? What is a runtime middleware? What is a UI layers? Okay. Next, you need to decide. You need to encode the rules in a libraries or you want to run every time without human forgetfulness. So we have a scripts. And last is we need to know the monitor update. So we need to check how the attacker evolved. So you can able to filter based on the new thresholds and everything. So these are basically the part of the functions which is required to build the guardrails. So is this clear? So if I go back, this is what we have discussed. So here, the first thing, now you get the clarity here. The first is basically called what we need data, batch source, streaming data, ETL we have, transformations and all that. Then we process the information and all data store here. But on that, we need to apply the governance. Okay, what is governance? Classify, label it, make sure consent we have for every data we have collected, quality has been checked, and enforce has been done. Any kind of a record we can capture in the audit logs. Does it make sense now? Does it make sense? And you enforce the policy to make sure right set of data will be stored. Is it clear? So that is basically the first thing. Now, the second part, this data, we go to the models. So algorithm selection, depending upon the AI you're building, data splitting, train the data, train the model, validate tuning so it can produce the right data. But make sure before we go for live, it need to cover all these criteria like drift detection, approval workflow, training governance, bias and fairness, everything is required. Is it clear? Then only it will pass. Then we basically have an application where we deploy. Okay, so we have workflow and everything. Okay, we have a decision support and everything, but the question is basically what kind of a decision you can control. So transparency notice, third party risk, logging, input validation. So these are basically required. Now all these data pointers, if you can see here, all these data pointers. Okay, parallelly, you can see the security APIs are there. Can you see that? All the logs, all the data, all the things are basically recorded in a security here, loggings. And that login data will basically go to the dashboard. In the dashboard, I can see what are the threats, what are the performance monitoring, and everything is there. Now, does it make sense? What is AI governance architecture? So you can basically decide what controls we need, and according to that, you can able to manage.